Okay. Hello, everyone. The attendees are slowly joining. Thank you for joining us today with 2 minutes delay to this webinar about smart waterways, inland waterways, called Building Climate Resilient Inland Waterways and focusing on the innovations for the future. We can look a bit at the agenda. So today we will have can we go to the slide? Yes, a very short introduction about the topic by myself. I'm from Magellan Circle and I'm the communication manager of the Renew project. Then we will go a little bit more in detail into the three projects that we are presenting here and the innovations that they have been working on with Marta Zuzilo representing CRISTAL project as the project coordinator from the Poznan Institute of Technology, followed by Orestis Tsolakis, who is the technical coordinator of CRISTAL from CERT. Then we will have PLOTO project with Professor Dimitrios Vamvatsikos from University of Athens as technical coordinator of PLOTO. And finally, we will also have George Sariglianis from Inlecom, who is the technical coordinator of Renew. After that, we will have time for questions and answers. Please put your questions in the question and answer box and we will answer them then. And maybe just specify if you're referring to a specific project, which project the question is referred to or to which speaker. If we don't have enough time to answer all questions, we will be answering them later on via email. So don't worry, we will try to answer all of them. And then we will have, let's say, a final closing slide focusing a little bit on the upcoming events for some final events of the project in 2025 that you're very welcome to attend. So we can go to the next slide and start with a little bit of the story of inland waterways and how these projects have come to life. So Europe has 37,000 kilometers of interconnected waterways, which offer a cost-effective, energy-efficient, and environmentally friendly mode of transporting goods. And while for a long time they have been a cornerstone of a European trade, their potential is not really fully realized yet. We can go to the next slide. So in Europe, we do need a transformative shift towards safer, more resilient and sustainable transport and smart mobility services. And to respond to all these needs, three sister projects have emerged from the same call dedicated to supporting this transition within the inland waterway transport sector. And these are, as announced before, CRISTAL, PLOTO, and Renew. Go to the next slide.
Is it?
Yes. So even though they all reply to the same answer to the same call, each of these projects have different goals and they are complementary in their approach to enhancing IWT. There are quite some similarities, but also quite some differences. And today we are going to look at both of these and how these projects are unlocking the full potential of inland waterways for sustainable freight transportation. These projects, they also target specific sectors and target audiences like regional and national water authorities, ministries of transport, freight companies, reinsurance companies, shipping industry, and the IWT research and industry community. But also at the end, at the end of the day, they can improve also a regular, let's say, citizens and the general audience as well in the services they provide in the long run. So if you look back at the agenda, this was a little bit of an intro to the projects. Now we can give the floor to Marta, who will present CRISTAL, and then Orestis, who will present a little bit more the technical details of CRISTAL. Marta, the floor is yours.
Thank you very much, Andrea. Just give me a sec to share my screen. With the presentation about the CRISTAL project. I hope you can all see my presentation. So hello once again, good afternoon. My name is Marta Zuzilo. I represent Łukasiewicz Poznan Institute of Technology. And today, together with Orestis Tsolakis from CERT, we will try to present you the main assumptions and goals of CRISTAL project. Let me the short information about the with general information that CRISTAL project is, as all those three projects, is funded by the European Union under the CINEA. Here you have the call number. This call is connected with safe, resilient transport and smart mobility services for passengers and goods. Here you have the numbers strictly connected with the CRISTAL project. Our project began in September 2022. We have, so now we have started the 33rd month of the project. We have 15 project partners. We are working under 12 work packages. Also, we are obliged to deliver 42 deliverables within our project, and also we should achieve 7 milestones. What is really important from this slide is that we have 3 pilot sites in which we are testing the technological and organizational solutions. Our project will end this year, maybe not in August, because we are working on some extension, but for sure our project will end this year. When we are talking about the CRISTAL project consortium, it's important that it's built, it's co-created by 15 partners from 9 countries. All of them you can see in this slide. The most important partners are connected with river pilots, and the river pilots are developed in CRISTAL project in Poland and operating in Vistula and Odra River. In Italy, it's Po River, and in France, connected with Moselle and Seine River. Here you have the clear information about all the CRISTAL partners, and as I mentioned, Łukasiewicz-Poznań Institute of Technology from Poland is the project coordinator, but also we have excellent work package leaders and other partners who are obliged to deliver all project outcomes. We have 3 pilot sites, as I mentioned, and French and the Italian pilot is coordinated by Union Trasporti. French pilot is coordinated by VNF. They are both infrastructure managers, and Polish pilot is coordinated by University of Gdańsk from, of course, from Poland. Here you have the information about the pilots, and all 3 pilots are involved in co-creating and testing CRISTAL innovations, which means in our project digital platforms for decision support, also technological solutions and sensor devices, as well as governance and business models. Now let me tell you a few words about the project goals and assumptions. The CRISTAL project focuses on the development of inland waterway transport and its infrastructure. We are working on creating an innovative technologies for monitoring and digitization of transport chains. The technologies developed are being tested in the CRISTAL project, and the results will enable us to develop business and governance models that will ultimately increase the practical use of river transport in multimodal chains. But when, of course, we are all aware that the project will not change the overall situation regarding the use of inland waterway transport, but we have the really strong ambition to contribute achieving global effects, such as shifting 20% of freight traffic to inland waterways. We would like to also increase the reliability of transport by 18% at network level with the use of synchromodality and the integration of inland waterway transport to multimodal supply chains. Through our activities, we also like to increase the operational efficiency and resilience of infrastructure, ensuring 50% operational capacity during extreme water events. And finally, we want to facilitate practical use of inland waterway transport by developing developing new governance models, enabling cooperation across institutional, modal, and national boundaries. When it comes to project challenges, the practical use of inland waterway transport in multimodal supply chains, it's not a simple matter. We all know that, and we are all aware of that. During the CRISTAL project, we face many challenges that we strive to overcome. The first one is connected with strong competition from other land modes, like, for example, road transport, which seems to be more flexible, but also more polluting. We also are aware that the waterway infrastructure in many European countries requires some kind of renovation, modernization, as well as requires regular maintenance, and all those activities are connected with high costs. Of course, we all faced with climate changes, and those climate changes causes also more and more extreme weather events affecting inland navigation, like floods and droughts. During the CRISTAL project, we experienced flooding in southern Poland and also in Italy. But on the other hand, we also encountered droughts in Poland, and low water levels in the Vistula River prevented us from carrying out planned voyages and making some research. Of course, the next challenge, which are connected with the CRISTAL project, as well as, I suppose, other projects, is low level of digitalization in inland waterway transport, which prevents full exploitation of rivers' untapped potential. And the last one, but also important challenge we have to face is that is connected with public perception. Still, inland waterway transport is considered slow and less low efficient, and still seems difficult to apply in practice. That's why it's considered like, let's say, unattractive transport mode. Now let me give the floor to Orestes, who will tell you something about the CRISTAL innovations which we are developing within the CRISTAL project.
Thank you, Marta. Let me just share my screen. I hope that you can see it. Okay, perfect. So hello from my side also. My name is Orestes, and I'm a research associate at the Hellenic Institute of Transport. In my part of the presentation, I will try to briefly explain how we try to tackle these challenges that Marta has just presented, while at the same time we unlock the potential of inland waterways and inland navigation. What is our approach in the CRISTAL project? Everything comes around the increase of the attractiveness of the inland waterways. And we want to achieve this by increasing the resilience and the reliability, not only of the river infrastructure, but also the resilience and the reliability of the operations in the rivers. To do so, in the CRISTAL project, we developed a set of innovations, while at the same time we try to develop appropriate governance models that will support the implementation of these innovations. The CRISTAL innovations can be separated in four main categories. The first one has to do with the technological solution, and more specifically with sensor devices that were implemented. The second has to do with the digital systems that are mainly targeting the decision support in different levels and in different fields regarding inland navigation. The third is innovative models, more specifically the business and governance models that are developed in the CRISTAL project. And finally, we also have some initiatives that are developed in the project pilot site by the pilots themselves. Here we see the 3 pilot sites in France, Italy, and Poland, and the innovations that were implemented in each of the cases. Some are common, like as you can see, the green fields, the digital innovations, the platforms of the project, while we have different implementation of sensors, technologies, own initiatives, and business models, depending on the specific requirements of each pilot site. Also a few words about the architecture, because the sensor technologies, the digital twin, and the CMS, which are the main innovations of technical innovations of the project, are all linked together, and this happens through this high-level architecture. We have the sensors. 2 of them are mostly related to the navigability of rivers, while we have the other 2 all about measuring things that are related to preventive and predictive maintenance of river infrastructure. So through a data broker of the system, these communicate initially to the digital twin, providing their input, and then the output of the digital twin, again through the data broker, is consumed by the synchromodal corridor management system, which is more related to the operational side of inland waterways systems. The sensors, as I said, are separated in 2 main categories: the acoustic emissions and the surface inspection radar. They are both targeting to identifying issues in the infrastructure by detecting microcracks. In the first case, in the acoustic emissions, we have sound waves, and the system is installed on locks, metallic lock doors, while the surface inspection radar, where we have a radar wave, this is installed in the concrete walls of locks. Both of these try to early identify problems that could cause disruptions in the close of locks in the near future, in order to start the process of maintenance or repairs. In the other categories, the fiber optic sensors and the smart buoys, in this case, actually, especially in the smart buoys case, we have multi-sensors installed in this system, where we collect information that are related to the navigability of the river, but also other information like weather, barge traffic in the rivers, and this kind of information. The fiber optic sensors, again, besides the navigability in terms of the water depth, it also calculates, can calculate the piling of the sand that create problems in navigability of the rivers. Now, the input of all these sensors is communicated, as I said previously, through the data broker to the digital twin system, which performs its calculations through the developed algorithms. And then the output of the system is provided, on the one hand, through its dedicated user interface to the infrastructure managers, through who can use this information to actually plan, schedule their operations for keeping the infrastructure status in a good condition. And on the other hand, the output, but now looking at it from the operational side of things, is then communicated to the SCMS. These are 2 screenshots from the digital twins. The one on the top is related to the 3D visualization of a lock in Italy, and also the input that comes from the surface inspection radar, while the other picture is about the digital twin of the river Po, that is related to the forecasted navigability in terms of the water depth in the coming days. Our last innovation is the synchromodal corridor management system. This is actually a platform that is addressed mainly to the operational stakeholders, which consumes the information from the digital twin, and through the digital twin also from the sensors that are implemented in the project pilot. And the main purpose is to alert and help in their operational decisions these stakeholders. In addition to that, it also helps support decisions at a different level, at the policy making level, at regional, of course, level also. This system has 4 main components. I will go shortly through each one of them. The first one, which is called Early Detection and Info Service. The purpose of this service is to actually collect in one point all available information that is today published, and is related to the status of the river and navigability status of the river, like the notice to skipper or any other source that is currently available, through a predefined standardized structure, digital structure. But in addition to that, this is where the digital twin communicates with the CMS and gets the information also for forecasted alerts from the things that digital twins predict. In the second component, the second functionality, we have the disruption impact identification service. This actually helps the users, the operational stakeholders, to use this information, both the existing one and the forecasts from the digital twin, and through their request to assess one planned route that they plan to do for transporting cargo in the river, and assess if this is feasible. So the system actually projects this transportation and sees it falls on some of these alerts, and then draws a conclusion about if this trip can happen, if it is feasible, if it is not feasible, or if it is feasible under some constraints. In addition to that, of course, this functionality calculates also other aspects like the emissions of this transportation and the estimated time of arrival if everything goes as planned. Now, the third component, the action toolbox of services, its main service is related to the previous one, and actually is the one that helps the decision support for action or no action in case that a disruption is identified. So if a route is not feasible or feasible other constraints, we have this service that provides a visibility of the alternatives involving the other two modes of transport, road and rail. Obviously, preferably rail because it's a greener mode, but in any case, it allows the user to have a knowledge of what he can do in case something goes wrong in this transportation. So the actual output of this service is to create this level of confidence, and also at network level to increase the reliability and help maintain the continuity of operations when something happens to the river. In addition to that, the action toolbox of services has also some custom-made services, if I can call them like that, that are mainly developed for specific needs in the case of the project pilots, like, for example, a track and trace functionality in the Polish pilot case, or a smart bulletin functionality in the Italian pilot case. I will finish the CMS presentation with the corridor observatory, which is actually an observatory collecting both static and information from the system operation, aiming to actually provide this visibility to policymakers about issues on the river, how the river performs, and what can be done to improve its functionality. I will finish my presentation with some lessons learned from the CRISTAL project. And these are mainly related to the fact that inland waterways are actually very complex transportation systems, more complex than any other we believe that we have, and they are affected in so many parameters that actually makes the system very uncertain. And it's especially now with the climate change is very difficult to predict. So creating systems that can mitigate this uncertainty is very important if we want to attract more cargo in the rivers. And the other lessons that we learned by implementing this project is mainly related to the lack of digitalization, because especially in smaller rivers, there are still a lot of things to be done in the way that we collect, store, and exchange data. And also, we need to do a lot of things also in terms of data sharing. Of course, this is an issue in the entire logistics sector, not only in inland waterways. Finally, exactly because in the case of smaller rivers, we don't have this very much developed transportation in the rivers. We don't have many established alternative services, which makes things even more difficult if we want to integrate rivers into a multimodal corridor. In the CRISTAL project, we actually try to overcome these things, starting from the bottom by actually using the project living labs to foster the collaboration among stakeholders and the exchange of data and information among them, while at the same time we provide this interconnected, interoperable infrastructure, combining sensors, digital innovations, the digital twin and the CMS to provide our services and make rivers more predictable and thus attractive. At this point, I will stop. Thank you all for your attention, and Andrea, the floor is back to you.
Thank you, Orestes and Marta. We are running a little bit of time, so even though there are 3 questions related to your presentation, but we can try to get to them after we have seen all the projects. I would like to invite Dimitrios now to present PLOTO.
Okay.
And to turn on his camera.
Yes, camera. It's slightly stubborn today, but it will yield to our collective presence. Okay, let's see, we can come on. Sorry, guys. Hide floating meter controls. Excellent. Already. Super. Okay, so hello, everybody. We're from the PLOTO project, and together with my colleague Vasilis Meliskianos, and then also from Dimitris Deparas, our former coordinator, and now Malan Audrey. We have been working a lot in this project. The official name is Deployment and Assessment of Predictive Modeling, Environmentally Sustainable and Emerging Digital Technologies and Tools for Improving the Resilience of Inland Waterways Against Climate Change and Other Extremes. In many ways, you see similar words, resilience, of course, inland waterways, climate change, and the targeting of the Commission and the proposal overall, the call for the proposal is quite obvious. In our case, the similar starting point, you might say, and you can see how different projects and different people interpret and focus in different aspects of something. In this case, we're discussing also tools and services, emerging solutions, a lot to do in contrast to what was shown earlier for CRISTAL. We don't have a lot of local sensors. Instead, we focus a lot on Earth observation. So part is UAV, but a large part is also satellite observation. And we offer a big focus on the part of risk assessment in the sense of risk as in quantified risk, and I will go into that a little bit later. Again, same tools, similar tools, same objective in the end. We want to reduce the effect of climate change. We want to improve the resilience of the existing inland waterways and essentially protect the environment around them. Now, it is a pure technological process, but as always, there is a lot of effort to listen to the needs of the end users, and essentially the issues of designing pilot activities, making sure things work well with the lifetime of the project and the working of the end users themselves, and agile development and startup mentality to ensure that within the 3.5 years, we can finish up everything. And in general, being able to produce some early prototypes. Make sure you stick to some schedules that would allow you to bring something up quickly, allow it to be tested, and come back, engage, get feedback, etc. You might think of today as exactly a part of this process. Now, 3 case studies for us. The first 2, A and B, are actually in Danube. Danube as in Budapest, which is an inland, the free port of Budapest is an inland port connected directly to a railway and highway, so it's a multi-modal hub. And of course, then there's the lower Danube area, which includes 5 ports in Romania, all the way out to the Black Sea. Case study C is separate, is the Meuse River in the region of Wallonie in Belgium. And again, for all these 3 case studies, we have issues of improving multiple hazard assessment, introducing improving, helping strategic management of the portfolios of assets and protecting the inland waterway, improving decision-making, both on the strategic sense, meaning long-term planning, and also operationally, meaning what do we do now, later, today, and scale things in actual critical parts of the inland waterway, meaning capture a reasonable, operationally large part that actually makes sense. Meaning not half a kilometer or so, but 10, 100, 150 plus kilometers. Just to give you an idea of how we structure this, I'm giving you a little bit of the, how, let's say, the logic stands behind this. Again, remember, a big effort for us is estimating the risk in the terms that would make sense to insurance companies. So a large part is figuring out hazards in the short term and in the long term, meaning essentially water, rain, winds, and earthquake. Then a build-up of the exposure model, or if you will, the portfolio of assets that are at risk from said hazards. And then connecting the assets into a network of assets, meaning they interact with each other, and disruption in one can disrupt the others. So there's a business operational model in the back. Interconnected networks, meaning power to water, to transportation, to railway, to blah, 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 freight, etc. Putting them all together you get your integrated software model, if you will, of your inland waterway and also of hinterland infrastructure. Now, what you put at the entry is, of course, the hazards. And in this case, prime hazard is the climate change. And it's the classic view of the multiple RCP scenarios, release concentration pathways, going from the, let's say, more benign one. If I may show this one here, the more benign ones that feel like it's nothing so bad, things are going to be like in year 2000 on average, to that'd be, let's say, for example, 4.5. Or you can go this big red line up here, which would estimate a global average warming of, well, several degrees Celsius, and wouldn't be a nice one. Again, such data is available for Europe thanks to Eurocortex, and we're able to use it and downscale it for this area, which is the Danube, pretty much, and this area, which is Wallonie. Now, earthquakes are treated in also a similar format, but now you have a seismic source model. Seismic source models allow you, for example, for the lower Danube or a part of Greece in this case, we're showing as an example, to figure out what's so-called field of intensity measure values, meaning an event, an earthquake happens, and it gives you simultaneously this kind of intensities over a wide area, over a long corridor, and you're able to figure out at the same time what kind of impact you're going to have at your distributed infrastructure. And we're talking distributed infrastructure over several tens and hundreds of kilometers. You have a set, these are the so-called beach balls that each one represents a so-called earthquake rupture. And through these combination with the localized IM fields, which essentially you might say they downscale the seismic motion, you are able to figure out what's happening on your infrastructure on one-to-one basis. Combine intensity measure fields, the exposure model, meaning your assets at risk, and of course the vulnerability of each individual asset to wind, rain, flood, earthquake. What you get is the so-called exceedance probability or loss curves of your assets in the long term. You get loss maps, meaning what gets damaged, how much it gets damaged, and how much it will cost you per event, per year, or essentially the average annual loss that insurers quite often like to hear. Of course, in the back, there is an operational model of how the port operates, not just one, all of them together. And you'll see, for example, the maritime and inland ports of Danube. They have both ships coming from the Black Sea and barges coming down the Danube, coming in. You have inland transportation going in. You got unloading, loading, storage, and back again. And that's how the model, the multimodal hub operates. Put this all, the operational model, into your computer. Make sure you feed it with the right information, and you can track every disruption and the recovery after the disruption for multiple realizations, tens and hundreds of years, and figure out how your port in its current or in an adapted, upgraded condition will operate. Overall, as well, if you want to see how the impact of a major port, let's say the free port of Budapest, will hit the capital of Hungary, you can actually do that as well. You can figure out the socioeconomic impact of the facility on the community, and we're able to develop models that assess the impact of natural hazards on the port and the nearby community due to weather events, earthquakes, etc. Meaning, this is not just about how much money you lose every time something hits, but also how much business you lose and how much your society loses in its economy at large. So, to sum up, some basic outcomes we're hoping to get by the end of the project: a climate-aware crisis management, including real-time weather information that goes into through sensors, risk models and assessment of inland waterway element vulnerability under multiple hazards, analysis framework to enable the flow of information from hazard and sensors to system risk and resilience, and a system that integrates the data from all these three remote sensing levels of satellite, UAV, and ground-based sensors, with a focus on optimal use of different sensor types. Finally, all of this part gets integrated in a modeling and simulation environment to assess the risk and resilience of the inland waterway. And at the end, we have our PLOTO integrated prototypes and the execution of the project pilots, meaning getting real actionable data to our users. And hopefully, we want to improve navigability, help waterways during extreme weather events, enhance infrastructure resilience, and ensure the smooth functioning of set ports in our use cases. And with that, thank you very much. If you need more information, you'll find it here and from our organizers. Thank you.
Thank you very much, Dimitrios. Very clear. And we're back on time. So, but I anyway suggest we continue with Renew with George Sarigiannis from Inlecom, who will present the Renew project before we go back to the questions for all three projects. George, the floor is yours.
Thank you, Andrea. Hello, can you hear me at first? Okay, great. So let me start the sharing. I hope you can see my screen, okay?
Yes.
Great, thank you very much. Okay, so hello everyone, and thank you for joining, and thank you for inviting us also in this workshop. My name is George Sarigiannis, and I'm a research and development manager in Inlecom. And today I will be presenting the Renew project that is part of let's say, the resilience and sustainable community, and also sister project with PLOTO and CRISTAL. And I'm acting as the technical coordinator of the project, and I will give you a brief, let's say, overview of the project so far and what we have achieved. So, a brief, let's say, idea of Renew. Renew plays a key role in promoting economic growth and minimizing the negative impact on the environment, as well as significant and lasting degradation of ecosystems. How we do that is by combining the technological advantages of digitalization and automation, as well as autonomous barges, including both infrastructure interactions that will revolutionize the future of IWT systems while we deliver climate neutral and climate resilient inland waterways transport services. Our consortium consists of 24 partners from 11 countries with 4 living labs, and the span of the project was 36 months. The project will end soon on August 31st, will be the final, let's say, day of our project, where we'll present all our results. Moving forward, the challenge of Renew to begin with was that as climate change affects the performance of inland waterways transport operations, the priority is to create and test new solutions and innovations for climate neutral and climate resilient inland waterways transports. Thus, the IWT system resilience is essentially codependent on infrastructure and barge fleet reliability, maintainability, and fault tolerance. So our goal is to achieve this, let's say, these three points. Our priorities within Renew are to provide sustainable infrastructure adjustments, the environmental friendliness and competitiveness of vessel fleets, digitalization of the entire, let's say, IWT ecosystem, the integration of IWT in multimodal transport chains, and of course, securing the availability of skilled workforce. Renew will deliver actually. First, a decision support framework that includes a resilience and sustainability quantification index that supports the strategic planning and operational optimization of green resilient IWT. Then, an innovative infrastructure resilience and sustainability solution that targets rapid deployment after disruptive events, that includes also modular platforms and pontoons, and of course, green energy solution. A green resilient IWT data space and digital twin that provides data sharing for infrastructure monitoring, standardized river information systems and traffic management, as well as emergency systems and climate solutions. Moving on, we have the 4 living labs that these solutions are going to be implemented and are already being implemented. Our 4 living labs that focus on integrated inland waterways and hinterland infrastructure, and living labs addressing specifically inland waterway resilience. These living labs include both digital solutions and physical solutions, so you can find both things there. And finally, as every project, we have the outreach and upscale of our program that is designed to maximize the impact pathways, and of course, always following the agenda of the European Commission in terms of sustainability and resilience. So a brief overview of the 4 living labs. Our first living lab is in Ghent, and it's the multifunctional synchronodality resilience city logistics hub. Then we have the Smart Douro Inland Waterway Infrastructure Resilience Management, which is Living Lab 2. Living Lab 3 is a digital lab within the corridor of Netherlands. It's the EU-IWT Network Resilience and Mitigation Digital Twin app. And finally, we have the Living Lab 4, which is the autonomous navigation application. A few words now about our living labs and where we have the solutions being tested right now. The first living lab, which is the Ghent hub, as we call it in short, our idea there and our goal there is to create a flexible and resilient logistics system for multi-users and multifunctional purposes. These solutions include remote control rooms and flexible infrastructure with modular platforms. The focus of this living lab is on the impact of events that are caused by climate change and within the operations of the city logistics hub. As mentioned, the location of this living lab is in the city of Ghent, a sea canal between Ghent and Belgium and Terneuzen in Netherlands, and it includes also canals, rivers, and canals with tidal action and a wide range of infrastructure. So, in summary, it's between Belgium and Netherlands, the corridor. This living lab is actually going to be also presented within our final event. So as Andrea mentioned, we'll mention again also in the end, we will have a final event soon, and we can see actually in person the Ghent Living Lab in action. Moving forward, we have Living Lab 2, the Smart Douro in short, which is within the Douro River in Portugal. What we're doing there is developing a digital twin for modeling the river behavior, and this is especially done for drought and flood analysis that is done in real time in order to predict, and also have a side focus that is on managing pollution from the vessels that are going through the river. As I mentioned, the location is the Douro Portuguese Inland Waterway that is also included in the 10T, and the corridor, yeah, it's the Atlantic corridor. We have then Living Lab 3, which is the Netherlands, and it's the Netherlands app. The plan there is to develop and demonstrate a planning for inland waterways transport resilience and environmental risk mitigation facility that also boosts modal shift. So we have an app that is a route optimization, and we can use it in terms of when we have serious, let's say, issues within the network due to some disruptions that happen. We can use the app that we're developing through Living Lab 3 in order to have, let's say, the best route given by the system, and follow that route within the vessels, and avoid any shifts, let's say, in the program. So the location corridor of Living Lab 3 is Netherlands, Belgium, France, Germany, and Austria. So this app will be used in several, let's say, countries. So it's a cross-border app. Finally, we have Living Lab 4, which is the autonomous navigation. Living Lab 4 actually focuses on simulating and optimizing autonomous navigation across cross-border, again, inland waterway corridors in order to evaluate the resilience, infrastructure needs, and economic viability. We will leverage digital twins technology that are already being developed throughout Renew, AI-driven route optimization, also used in Living Lab 3, and regulatory assessment in order to advance scalable, low-emission, and crew-adaptive solutions for future inland navigation systems. The location of this Living Lab, since it's a digital Living Lab and everything will be done as a simulation, it's from Ghent to Duisburg. So we will be simulating how a vessel, an autonomous vessel, would, let's say, comply based on the, let's say, new directives and based on all these technologies in terms of navigability through these corridors. Moving forward, sorry, okay. We have a brief, let's say, Renew in a nutshell, as we call it. It's a complete idea of what Renew is about. So you can see on top, we have the 5 pillars of Renew: the improved navigability capacity, the enhanced inland waterways infrastructure resilience, the increasing modal shift, the smooth functioning of passenger and cargo mobility, as well as the reduced environmental impact. These are the five pillars. And how do we achieve it? Is that we have three pillars underneath, which is the digital transformation, the engineering, and the business. So what we do is that we combine engineering aspects, physical tools, as well as digital tools, and combine them in order to have, let's say, the business pillar that includes the goals of the European Commission and, of course, the goals of Renew. Currently, we are already at let's say 90% of the project in terms of development. You will see actually the developments through our final event. So please do join if you're available. And as a final remark, I would say that by, let's say, closing this project, we will see also with Renew and CRISTAL, we will see a huge change within the resilience sustainability within these, let's say, corridors, the inland waterway corridors. I think that, yeah, and here we have our consortium, the 24 partners that are included in Renew. And I think that this will conclude my presentation. I was really brief, Andrea.
Thank you, George.
Thank you very much.
Okay. So thanks for finishing on time. We have now some time for questions. There was already a few questions answered by Orestes in the question and answer box, but there are a few more questions that I might read out loud, and then I think they are kind of referring to all the projects. So I'll read out the first one, and then we can see who could answer. One is about barriers to the deployment, let's say. So what are the key barriers, technical, regulatory, or economic, that limit the uptake of these digital solutions in IWT? And how can EU projects like CRISTAL, PLOTO, and Renew overcome them? We have a volunteer, maybe, to answer
Andrea,
this
can
one.
you repeat the question again? Because on my end, you were a bit disconnected for some time.
Okay, so
Yeah.
it's what are the key barriers to the uptake of digital solutions in inland waterway infrastructure? Key barriers in terms of technology, regulation, and or economical ones, and how and if EU-funded projects like these three projects can help overcome them.
Okay. Can I just be the first one to give some
Yes,
answer, and then
yes.
our rest, let's say, coordinator can join. So on my end, and based on what I've seen from all the three projects, and of course, especially Renew, since we're the technical, let's say, leadership of Renew, I can say that we have already faced several, let's say, issues in terms of how to adapt, mainly in terms of, let's say, regulatory terms, because when you have cross-border and cross-national living labs and testing grounds, it's not really that simple to actually abide and follow all the different regulatory terms and, let's say, points that each country has. And you have to adapt to all these issues in order to present a complete pilot case that goes from one country to another. So in order to follow all these points and be sure that you are actually upscaling the living lab and showcasing your solutions, you need to study a lot, discuss a lot, and actually contact several authorities from all the countries that get together and discuss and see how you can be okay with every country's regulatory affairs and still also provide the innovation within the living lab. Apart from that, on my end, as also the living lab leader of Renew, I would say that the main point would be that the living lab participants and the stakeholders involved should be actively involved and always keep them interested and always keep them engaged and have regular discussions and get-togethers in order for its living lab to actually proceed and have a good, let's say, end result for its pilot. So I think on my end that those two things are the main key points.
Mhm. Thank you, George. Any comments from Orestes or Dimitrios or Marta about the specific question, or shall I go to the next one? Dimitrios, please go ahead.
Yes.
Tell us your review.
I can offer my experience on our side, and so what I've seen so far is that there is anytime we want to, let's say, replicate our solutions, there is a significant cost to the user in terms of personnel. They have to put the time in and help us out with data, help us model, help us, let's say, create, if you will, the digital twin of what they have into our systems. And that is, I mean, it takes time. It takes time, it takes data. And quite often, I mean, they're not, I mean, it's a threshold. Okay, you have to go over that threshold. Once you go over there, the rest is smooth riding. But quite often it's not easy, or so I've seen in other similar projects, to convince that it's worth it. Once they get it, though, they like it. That's the interesting thing. It's like, ChatGPT. Somebody offers it to you originally for free. It sounds good, and then you get used to it. But if they told you it costs 100 euros per month, you have a difficulty deciding to go for it. So it's a mixed bag, if you will.
Marta.
Yes, if I may add something, I just would like to say that I think that these barriers depend largely also on the specific characteristic of individual countries, because the practical use of development of inland waterway transport varies across Europe, which is also determined by the types of the rivers, and we have to remember about it. For example, rivers in Poland are mainly fed by precipitation and snowmelt, and sometimes partially by groundwater. And low rainfall causes water shortages in rivers, and sometimes even make it impossible to use this mode of transport. And river routes in Poland, for example, are simply impassable sometimes. So in this situation, some kind of investments in technological solutions for monitoring river infrastructure or maintaining it in some kind of proper condition sometimes become simply unjustified because the risk is too high. So from my perspective, it depends of individual countries, because in other countries the situation can be different, and the barriers can be connected with what guys previously said. So we have to remember about those specifics of different countries.
Mm-hmm. Thank you, Marta. We have some other questions, but we're not going to have time to do all of them. So I have another one that I think is interesting, because we keep talking always about the future. And this one would be looking back at the past. Have our inland waterways more resilient today compared to 10 or 20 years ago? Who could answer this one?
Okay.
No. Can I take it quickly?
Yes, let's start with Dimitrios and then
Yes,
George. Yes.
I'll go for the easy answer. It depends. And now I'm gonna let George say what it depends on. Go, George.
Thank you. My answer would be again, it depends, because there are several things that have changed throughout all these years. But it's not just that we have more resilient or sustainable, let's say, waterways transport. It's that also the events that occur now are really more intense and more and stronger in several terms. So yes, you can consider them more resilient and sustainable than they were in 20 years ago, considering the let's say extreme events that occurred 20 years ago. But if you consider the events that are happening right now, we can consider them, of course, in some terms resilient or sustainable. However, I think we are a bit far away from, being up to the current events. I think we're doing our best efforts throughout all the projects and of course, through our 3 projects here, to actually manage to catch up with the events. But there is a lot of effort to be made yet in order to say that we are up to date with how the events occur right now. And I don't know if anyone else wants to comment on that, but this is my view, at least, as a scientist and as a, let's say, disaster crisis expert.
Orestes, maybe you can give your point of view.
Thank you, Andrea. I agree with both opinions. Actually, yes, we try to make rivers more resilient, but let's keep in mind that today we have a larger need to be resilient. This is why these 3 projects exist, which means that things are going worse. I mean, the climate changes and the weather events are more and more intense. So while we do have the tools, we do have the project, we try our best. I'm not sure that we have yet managed to keep up with these events, but I think that we're in a good path.
Okay, thank you, Orestes. There are some more questions, but we, as promised, we will try to answer them via email, also related to extreme events and climate change and how it affects IWT. I would like to go on to the next and final slide, let's say, and invite all of you who have come today and are interested in these 3 projects to, if you're attending or still haven't planned to attend some of these events where different projects will be present. For example, the ITS European Congress in Seville. We will have a session on inland waterways with Renew and PLOTO. It's session 53. And there will also be a stand of Renew and PLOTO at PNO and Ertico stands. So some of you might know this event. If you are there, please pass by and attend the session as well. Then there is the Transport Logistic 25 in Munich, Germany, a very well-known biannual event. Renew and CRISTAL, we will have a stand there with Alice, and indeed this participation will focus on the technical innovations of the project. So don't hesitate to drop by the stand there as well. Then a big one that is also a free event, unlike the others, is on the 19th of June, Thursday, the Renew final event and demo in Ghent. So Renew is ending in August. We're organizing the final event in one of our Living Lab sites, and there will also be a live demonstration on the Ghent canals in the afternoon. The more information is on Renew website, and the registration will open very, very soon. And then the final event, let's say before the summer period, is on 25 to 27 June. There's the IAAEME. It's the International Association of Maritime Economists event in Bergen, Norway, where CRISTAL will have a presentation. Once again, thank you for joining us today. All these presentations will be available on the Renew website and other projects, but I will also make sure to send you an email with the links as well to all those who registered for the webinar, and the recording will be available as well. And we do our best to answer all the questions that we have registered in the Q&A box during the webinar today. Thank you and have a nice rest of the day. Bye-bye.
Thank you very
Thank
much.
you, everyone.
Thank you.
Bye-bye.
Thank
Bye-bye.
you. Bye.